So here we're going to start into chapter 6, which a lot of it's going to be about exponents. So to get started here, we're going to do a review on some properties of exponents. So one is called the product rule, and that would be if we had something like x to the third multiplied by x squared, and determining what that gives us. Now, a lot of the times, and really throughout this whole chapter, we'll deal with shortcuts, but visualizing it is often helpful because x to the third is really x times x times x. X squared is x times x. So if we view it from a visual standpoint, we can see that it would be x to the fifth power because 5 x's are multiplying together. The shortcut is same base, add the exponent. So 3 plus 2 is 5. Power rule is if you have, let's just say x to the third power squared. So it's called the power rule because it's kind of a power to a power. This shortcut is multiplying, so this would be x to the sixth. Picture of that would be x cubed multiplied by x cubed, and then you can see there's the 6 x's. All right, so power to a power, you multiply. And then there's some when we have division, so our quotient rule, kind of two variations here. One would be, let's do x to the fourth over x. So what this would look like visually is we had 1, 2, 3, 4 x's up top, 1 x in the denominator. One set of those would cross off, leaving us with x to the third power. So the rule on that is you take your exponent, subtract the other exponent, and you can kind of see why visually. Another variation of this, though, I'll use the same numbers, is if we had 1x in the denominator and then x to the fourth in the denominator. So it'd be a similar picture, 3, 4. But now, when they cross off, I still have x to the third power, but it's now in the denominator. If you have nothing in your numerator, you can fill it in with a 1. Okay, so that's the quotient rule. Both variations. You can have your answer end up in the the numerator or denominator. Zero rule is if we have any non-zero number and we raise it to the 0 power, it's equal to 1. Now, a quick proof behind that, because that one seems strange to people. A picture rendition of this one would be if we did, let's do x squared, x and then x and x. They would simplify out, we'll kind of cross off. Or another way of thinking about it is, any number divided by itself is always equal to 1. Or you can view it as, x squared and x squared. They'd both eliminate into 1s, thus giving us the answer of 1. So there's kind of a quick proof behind why something to the 0 power is 1, because it's really just whatever that term is divided by itself. All right. Negative rule is, say we have x to the negative fourth power. We'll never leave negative exponents. This would cause us to take the reciprocal. Negative with exponents do not impact whether your answer will turn positive or negative. All they do is tell you to switch spots in the fraction. Once again, if your numerator is blank, fill it in with a 1. You can also have negative exponents in the denominator. Once again, the negative just tells us to take the reciprocal. So now I'd have x to the fourth up top. All right. So that's a quick rule. That would have been chapter 7 for you guys in Algebra 1. And one last thing that won't really come up today, but will as we move through the chapter. No, will come up today. Sorry. Is that square roots are the exact same thing as taking, so if kind of had an x underneath the square root, that'd be the same thing as x to the 1/2 power. The cube root of x would be the same thing as x to the 1/3 power. All right. So let's start to do some applications. So a root can represent the solution of an equation. So you might see this and be having chapter 5 flashbacks. But now in this chapter, we're not going to have polynomials. We will be solving for x, but we won't have to be doing any, any major factoring. Sometimes it might show up just barely, but most of the time it's going to be working with square roots, cube roots, or other type of roots. And here's how it works. If we just have x to the third power is equal to 27, there's two ways of solving this. Let's look at both ways. One would just be to understand that the cube root is the opposite of having something to the third power. So that would get us free, and then I'd take the cube root of 27. Another option would be to raise both sides to the 1/3 power. All right, and because this is just power rule, 3 times 1/3 would cancel out, leaving us with x, and then 27 to the 1/3 power, which is the same thing as the cube root of 27. So if you're out on the video, I can show you how to type in both or either one of these, depending on what your calculator can do. So both of these, whichever way you do it, because it's the same thing, give us the answer of 3. So we could say here, 3 is the cube root of 27. All right. So we'll talk about different implications in terms of what happened to our plus minus. Will it still be there? When will it? When won't it? All that type of stuff as we're exploring roots on through this page. So like the equation above, where we had x cubed equals 27, we can really do this with any numbers as long as a and b are positive real numbers and n is a positive exponent. Then there will be an nth root of a. Or would it be b? Hold on. Sorry. Nth root of b. Because that's the second. It'll cancel out on the for the a. And so we'll really be looking for the nth root of b. Like here, we took the cube root of 27 to get the x free. Okay? All right. So there's two scenarios. One is if our exponent is odd. So here we have x to the 5th power. This would just be doing it on the calculator. It's either the 5th root of x or x to the 1/5 power. Either way would be fine. And then also 3,125 to the 1/5 power. So if we had x to the 5th to the 1/5 power, getting x free. And the 5th root of that is a 5. All right. Now there's not a plus minus on that. Because with an odd number, it matters if that 5 is positive or not. Because 5 to the 5th power, let's write this out real quick, is going to have to be positive. If I put negatives with them all, these two would cancel, and then now my answer would be negative. So what that means for us is that we can odd root. So on this one, we could 5th root, which is the same thing as doing the 1/5 power. In this one, x would be equal to a -5. Okay? So with odd roots, you just get one answer. There's no plus or minus on there. Okay? However, if n is even, so over here, there's going to be two possibilities. So in this one, if we 4th rooted both sides here, we get x by itself, and that would be x is equal to 4. Also on this one, though, plus or minus. Because with it being to the 4th power, if it's positive 4, obviously we'll get positive 256. But if they're all 4 negative, we get 2 sets of negatives that cancel out to land a positive again. So we will get 2 roots. Or, now that we're done with chapter 5, as we're in chapter 6, we're going to pretend that imaginary solutions don't exist again, which is convenient for us. So this one here wouldn't be possible. So we'd say no real solution. All right, because there's no way to have an even amount of terms get a negative number, unless we use I, but we're not going to use I in this chapter. Okay, so with this, if you are taking an odd root, then there's only one solution. If you're taking an even root, then there are two solutions because of that plus minus, unless you're taking an even root of a negative number, then there are no real solutions. All right? But if you're taking an odd root, it doesn't matter if the number is negative. You can odd root negative numbers all day. Can't even root them, though. Okay? So when it asks what are the real roots, this is another way of asking for solutions, which is essentially saying x cubed could be equal to, all three of those different ones. So this is really just a calculator exercise here. So when we take the cube root of 0.008, we get that it would be 0.2. All right, now I can cube root negative 343, even though it's negative because we're doing an odd root, it would get us a negative 7. And then this one here you may or may not need to type in because you might know that the cube root of 64 is 4, making this one 1/4. Okay, and you can type all those in. All right, so looking for the real fourth roots, well, any power of 1 is just 1. This one here, it's negative. Don't even have to worry about it. It's no real solutions or no real roots. Those words are synonymous. Okay. Then this one, I could square root it very easily because both those are perfect squares. But this is going to end up being a decimal answer when we fourth root it. And if we were to fourth root this guy and round it to the nearest tenths, we get 0.85. All right. But something we have forgotten here, now it's kind of confusing because we didn't really visualize this as an equation, but when it's asking for roots and we're doing an even power, we would want those plus or minuses on there. Because, negative 1 to the fourth power would land at a positive 1. All right? Nice. Okay.